So this video deals with password-based authentication. The password is the oldest solution to authenticate users. As you know, this method has many drawbacks because it forces users to memorize passwords, having to comply with certain security constraints. And these security constraints make passwords difficult to remember. Nevertheless, the password-based authentication method remains the most widely used authentication method. Authenticating users is more challenging than authenticating a web server where public key cryptography can systematically be used. To authenticate a user must provide his credentials. A credentials is a piece of information to check that a user is who he claims to be. And there are different types of credentials leading to different authentication methods. Some credentials can be based on what the user knows. This is typically the case with password-based authentication that I will present in this video. Other credentials can be based on what the user has. This is typically the case with security token-based authentication. And other credentials can be based on what the user is. This is typically the case with biometric authentication that I will not cover in this course. And finally, it's possible to combine different types of credentials in a multi-factor authentication system. In password-based authentication, the credentials that the user must provide to the system to authenticate is a memorized secret and is called the password. This method is the most common method to authenticate users. Although it looks very simple, password-based authentication is not as easy to implement as it seems. There are basically two reasons that make this method difficult to implement. First, users tend to choose easy to memorize passwords, and such passwords can be guessed by attackers. Second, passwords can be compromised at the system level, and if the authentication server stores user passwords, compromising the authentication server will lead to the compromise of passwords. So let us first consider the problem of an attacker trying to guess passwords. There are different ways for an attacker to guess a password. In online guessing of passwords, the attacker uses the authentication system to check password guesses. And these guesses may be the result of some social engineering. The attacker collected some data about the target victim, like his birth date, the name of his children, the name of his dog, and so on. Without prior social engineering, online guessing is unlikely to succeed because most authentication systems limit the number of unsuccessful tries and deny subsequent tries for a period of time. However, sometimes the authentication system has a vulnerability that allows attackers to test unlimited number of passwords. And this happens regularly in different systems. And it happened recently in the Zoom video conferencing platform. And this vulnerability has enabled brute force attacks to crack passwords to join private meetings. In fact, if the authentication system allows for an unlimited number of tries, then several attacks become possible. The brute force attack, the dictionary attack, the covert channel attack. Let's see each of them one by one. In the brute force attack, the attacker simply tests all possible combinations of characters. In the Zoom vulnerability I have just mentioned, the password to guess was only a 6-digit numeric password, leaving only 1 million possible combinations that could be tested in a matter of minutes. It is considered that the brute force attack becomes infeasible if the password is long enough, at least greater than 8 characters, and consists of alphanumeric characters, that is, not only numeric digits as in the Zoom password. This of course has consequences for the user, since memorizing a password becomes more complicated. A more subtle attack and more effective attack than the brute force attack is the dictionary attack. The dictionary attack tests a list of common passwords taken from a dictionary. And such dictionaries can be downloaded from the internet and contain hundreds of millions of passwords recovered from past data breaches. Hundreds of millions. The probability that some of my passwords, some of your passwords are included in such a dictionary is not negligible. So from the user perspective, preventing a brute force attack or a dictionary attack can be done by choosing strong passwords. And there are some criteria to choose strong passwords. By strong, I mean passwords resistant to brute force and dictionary attacks. The password must be a combination of uppercase and lowercase letters, symbols and numbers that look random. The password must be at least 8 characters long. The password must be unique. That is, as a user, you must not use the same password for 2 different systems. This is to limit the risk associated with the compromise of one password. We all know that memorizing several long passwords that look random, one for each system we need to authenticate to, we all know it's a huge task. Fortunately, there is a solution which consists of using a password manager. A password manager is a tool to encrypt your different passwords into a database. And you can decrypt that database by providing another strong password, and this is the only password you need to remember. Modern browsers have their own built-in password manager. It's convenient, especially for users who always use the same browser and the same platform. For users using different platforms and browsers, a desktop password manager is a better choice. A good password manager should be cross-platform and allow synchronization of the encrypted database of passwords in the cloud. Let me very briefly present the Chrome built-in password manager. This password manager can generate strong passwords for you. It can locally store your passwords in an encrypted form. If you want to access to the local database, this URL will direct you to a setting page asking you to provide your operating system credentials. The Chrome Password Manager can also store passwords in the cloud if synchronization is enabled. If you want to access to the online database, this URL will direct you to a setting page asking you to provide your Google account password. And the advantage of synchronizing the password database is that passwords become available from different devices, provided of course that the Chrome browser is used. As for the guessing attack, I talked about the brute force attack and the dictionary attack. And we came to the conclusion that users need strong passwords to protect against these attacks. There is another type of guessing attack. This attack exploits a covert channel in the authentication function. Consider the following password verification function, which checks a user input against an actual password. This procedure is vulnerable to a devastating timing covert channel attack. Devastating because this attack makes it possible to recover even the strongest password in no time. So let me describe this attack. The first thing this authentication function does is to verify that the password length is correct. If the length is incorrect, the function terminates abruptly. If the length is correct, the function continues its execution. Consequently, If the computation takes a bit longer, then it means that the right length has been found. After the attacker has learned the password length, he can learn one character of the password at a time. If the attacker inputs an incorrect character, then the function terminates. If the computation takes a bit longer, then it means that the attacker has found the correct character, and the attacker can try to guess the next character. I already told you that this attack allows you to effectively recover the strongest password. The conclusion of this is that the execution time of an authentication function should not depend on the input. An authentication function is a security mechanism. It must be trusted code, free from any kind of vulnerability, including this timing covert channel. At the system level, passwords can be stored in a file that contains a set of username-password pairs. Of course, that file is highly sensitive and must be protected from unauthorized access. However, the system can be compromised. It is sometimes easier to compromise a system than to guess online a single password. And actually, the dictionaries I mentioned earlier, the dictionary used in dictionary attacks, are filled with passwords stolen from compromised systems. So to prevent passwords from being stolen, the best solution is not to store passwords. An alternative to storing passwords is to store their calculated fingerprint with a cryptographic hash function. For each account, the system stores a pair consisting of the username and the fingerprint of the password. This figure illustrates what I have said. Bob has entered his password hello123. The server does not store the password but only the fingerprint of the password. If the server is compromised, passwords are not disclosed. This is much more secure than storing passwords. However, it has a drawback. If Bob loses his password, then he cannot recover it. He can only initiate the password reset procedure provided by the server. Until now, I considered the online guessing attack to system allowing for an unlimited number of tries. An alternative to online guessing attack is to compromise the authentication system, in a way or in another, steal the shadow file, which contains a pair of login and fingerprint, and try to attack that file in an offline mode. The most effective offline attack against a file containing login and fingerprint pairs is to use a rainbow table. A rainbow table is a huge pre-calculated database of passwords and their corresponding fingerprints. Since Bob's password is a weak password, it is probably included in this rainbow table. So a simple instant lookup operation is all that is needed to retrieve Bob's password from the password fingerprint. Since attacks using rainbow tables are very efficient, people have tried to design better systems. To make attacks based on rainbow tables more difficult, a unique salt is added to each password at the creation of the password. A salt is random data generated by a pseudo-random generator when creating a password. A salt is not secret data. The server stores the salt and the result of the password hash concatenated with the salt. If Bob authenticates, his password is first concatenated with the salt in the shadow file and then it is hashed. If the result matches the hash contained in the shadow file, then Bob is authenticated. This technique makes attack using rainbow table more difficult because the attacker would need one rainbow table per salt. However, using salt does not prevent an offline dictionary attack. The attacker can compute hashes of known passwords concatenated with the stolen salt. In this example, the attacker wants to recover Bob's password. It chooses passwords one after the other from the dictionary and hashes them with the stolen salt until the result equals the stolen fingerprint. And the best way to discourage the attacker is to use a slow hash function. A slow hash function will not make much difference when hashing a user's password during authentication, but since the dictionary attack requires thousands and even millions of tries, a slow hash function will make this attack impractical. So do not use SHA-256 to hash passwords. Instead, use hash functions such as bcrypt or scrypt. So this video was about password-based authentication. I told you about online guessing attacks. These attacks exploit certain vulnerabilities in the system, allowing an unlimited number of tries. I told you about offline attacks using rainbow tables and dictionaries. These attacks require first compromising the authentication server. However, do not forget that the easiest way to steal a password is social engineering by using the phishing attack, for example.